In terms of review tests, you're supposed to have passed forward now the review test over here. We have them all up front, please. Okay, so just pass them over here in the corner, and we'll just leave them there for a moment. So this is review test, passing those over. And again, the idea is to have materials. Just a reminder that tomorrow I'm going to start the orange book, the counting unit. And that is one where you're just going to have materials you can read. Now, I think the orange book is on reserve, at the reserve desk in the library. So you might be able to, if you don't have a copy of that yet, go there to read it. But this is a unit that's going to spend or take us a few weeks. So we aren't just going to finish it up tomorrow. It's a unit that is going to push you a bit into some new areas. And it's something that over the weekend I expect you to spend a couple hours on, which may be a couple hours that you will find yourself not able to do everything, but it's important that you spend that time. So more on that tomorrow. Today, we're going to look at subtraction. And the method of subtraction that I'm going to present to you is different than what you may have done before. Now I'm going to start with some of the things I have on the board. I may erase some things today. I'm not sure just how I want to do this. However, most of us as kids learned how to subtract by taking things away. Okay, and we are going to approach subtraction in a different way. We're going to approach it as an addition problem. So if I ask you this problem that I have up on the board, 3 plus 2, we do an addition problem, and you know the answer is 5, and we call that a sum, right? Now, after you learn how to do that in school, one of the things that's often done is to do a different problem, and this is called the missing part. So 3 plus some number equals 5. Now, as an adult, you see a 2 there, I hope. No problem. But as a youngster, they have trouble with that. So finding a missing part of this addition problem is difficult for them. There's a related problem in multiplication. 3 times something is 6, and you find what? The missing factor. Same idea. One involving multiplication, the other involving addition. So the way to get around this problem is we take a subtraction and we write it instead as what? We trade this off for this problem. 5 subtract 3. And we talk about getting the difference. And so we teach children a whole new set of subtraction facts. We trade this problem off for what? 6 divided by 3, and you learn 100 more division facts. And kids get overload. Now the problem is, in most states, California, I know it's true, I suspect in many other states, there are certain times when you're supposed to cover addition, then there's another time when you're supposed to do subtraction. And because it is very set, we don't wait for young kids to develop where they should be to present subtraction. Now, as I said, most kids can't do this problem. Now, there's something related to it, and I have some diagrams here. 3 different glasses. And this is before sippy cups. When you have a young child in a high chair, a toddler, maybe not a high chair, one of those big, you sit them down inside and they're on the floor. Not a walker, but it has a tray on it and you can give them their food there instead of a high chair. What do they call that? Okay, I know we bought one for one of the grandchildren. Instead of being up high, it's down low. But it's still the same thing. You put their food on the table. You put a glass of whatever on the table. And if you were to just take a regular glass and fill it up this high, what's going to happen in the first 30 seconds? It's going to spill, right? Child just goes, whack, and the milk goes over. So with sippy cups, it goes over and nothing happens, and it's not a problem. But before sippy cups, you know what a sippy cup is? It's got a lid on it, and it looks a little bit like this with the lid on it. This is sort of a mature sippy cup. Okay, but it has a little lip on it, and if you turn it over, it's not supposed to spill as badly. It still dribbles onto the floor, but so you have a sippy cup. Before sippy cups, parents got very clever. They only put this much milk in. You're going to spill it anyway. What's the child's reaction when they see your glass and they see their glass? I want more. You have been unfair. And they let you know about it. And they protest. And you know the minute you fill it up, it's going to be spilled. So what does the clever parent do? You get an olive glass. This is the one where you get the olives and it's about this round. You fill it up this high, the child's happy, it spills anyway. And it usually doesn't break because it's so solid, it's very durable. And the child doesn't know they've been cheated. Now at some point they do. And then they protest again. Well, there's a related problem to this that I sort of like with kids when they're grandkids. Put a nickel and a dime and let the child choose. So you're going to give them some money. Grandkids come over. What would you like? A nickel or a dime? What'll they choose? The nickel. It's bigger. They have not adjusted the idea of amount versus the size of the coin. Okay, let me do one more. And these all tell you that the child's not going to be able to do subtraction right. This is one I write about later because it has to do with fractions. And it's the kind of thing as a child, more or less, I remember coming into the house. This was before video games and you played outside and you actually saw the sunshine and you stayed outdoors. We would play games. And before dinner, you were starving. And so you'd come in, and I can remember my mom cooking. She was busy, and I'd ask for a cookie. Sometimes I was just told no. Dinner's just a few moments away. But if dinner was going to be a while, or I had a friend with me, she'd take the cookie, say, you can't have a whole cookie. She'd take a big old chocolate chip cookie and she'd break it in half and give each of us a piece. Now, if you try that with kids, what's the reaction? Do they buy it? Will they take this piece of a cookie? Not happily, and sometimes just refuse it. What is the argument they give? Well, okay, the halves question comes in, and so you let the child choose which half they want. They're supposed to be the same half, but it's hard to do it. I still get tickled with family gatherings. You cut a piece of cake and say, I cut it in half. Who wants the larger half? A half is supposed to be what? Equal to the other half. But we still play that game. Now, it's not because the half is bigger or smaller than the other piece. What's the problem? Okay, it's cut in half. It's what? It's not a whole cookie. It's not a cookie. It is a broken cookie. Okay, so the child's upset, and you capitulate. I don't recommend doing this because you give in. But I don't want to get into child psychology. So you take the two halves and you do what? You put them together and say, here. And what does the child say? It's a broken cookie. But their pieces are there. No. It's still not a cookie. Try to explain to that child that when you add two halves, you get the whole. Their attitude is, no, you've got broken pieces still. Now, this goes under what's called intellectual development. And young children eventually will understand that they've been cheated with this glass. They will understand to take the dime, and they will take the 2 pieces of the half cookie unless it is involved with social relationships. And I always get amused. We talk about intellectual development, and we talk about how kids eventually will take 2 halves of a cookie and be okay. Then we break our hearts and try to put them back together again, and we're back to childhood. It's broken. It's not the same. And we didn't go back to where we were. Well, the method I'm going to present to you is one that I learned as a kid because I didn't get to go to public schools. Now, in the last hour, I found 4 people, first time I've ever had a class with 4 people in it, who all learned this method in public school. Well, I take that back. 1 learned it from their parent, but the other 3 saw it in school. It is how to subtract without borrowing. Now, the name I'm going to give to it is the name that was given to me, the Austrian method. Austrian method. So, Debbie, what I'm going to do is start with this problem here and explain the idea. Now, first, we know that 12 and you put a -5 and you get a 7. I hope you're comfortable with that. This is an arithmetic problem, and this is the way we typically write it. How? Pre-algebra. So if it's written vertically, we think of arithmetic. If we write it horizontally, we think of it as a pre-algebra problem. Very subtle difference there. So I give you problems both ways. Most of you, I suspect, would say 12 minus 5 is. I want you to reverse the process. Instead of going from the top down, I want to go from the bottom up. And so what I'm going to do temporarily is erase that 7. And I'm thinking now of a question mark there. What number plus 5 equals 12? Now you get the same answer. But notice I've changed the way I've asked the question. I'm not asking you to remember something that's subtraction. I'm doing it as an addition. So I'm going to put a number here that I'm going to add to 5 to get 12. And the answer is still 7. Still get the same number. So I'm going to try the same idea down here now. Now this is, again, an addition method. So we aren't going to start from the top down. We're going to start from the answer going up. What can I add to 6 to make 8? 2 and 6 is 8. What added to 4 gives 6? 2 and 4 is 6. 3 plus 2 is 5. 4 plus 3 is 7. I did an addition problem. Now, so far, you may still be in your head subtracting, so I'm going to push this a little bit further. We're now going to move over to the next numbers, and this will force the issue a little bit more. Now, what I'm going to do is change this back. It was a 3/8. This is my subtraction problem. So I have 7, 5, 6, 8, and I want to subtract 3, 8, 9, 6. So what I'm going to do is I'm going to look at the answer part and work up. So what added to 6 gives 8? 2. Agreed? Now this is not as easy. What added to 9 will give me a number ending in a 6? And the answer is 7. Because 7 and 9 is 16. So I'm going to carry the 1, change the 8 to a 9. I'm not borrowing. There's no borrowing in this process. Let's do that one more time. I needed something that I could add to 9. to get a number ending in a 6. So I have to know 7 plus 9 is 16. So instead of putting the 1 as a carry right above the 8, I simply cross out the 8 and put a 9. Now I need the next number, and I'm focusing down here in the answer. What can I add to 9 that gives me a number ending in 5? A 6. Do we agree? 6 and 9 is the 15. There's the 5. And what am I going to do with my carry? Cross out the 3 and make it a 4. What do I need to add to that 4 to get the 7? 3. Notice there was no borrowing, only addition. Are we okay there? Now, what I'm going to do is change the problem just a little bit because there's a trap you can get into if you aren't careful. Okay, and that was a 3 here. So notice I've changed it from subtracting a 3/8 to subtracting a 3/3. Bless you. Are we ready? Again, we're doing it as addition. So I have 7, 5, 6, 8, and I'm taking from that a 3, 3, 9, 6. My first number will be what? A 2. Is there an agreement? Just like it was before. The 2 added to the 6 is 8. My next number is still a what? 7. A 7, because 7 and 9 is still the 16. I still carry, but this becomes what this time?
4.
A 4. What do I add to 4 to make 5?
1.
A 1. Was there any carry? That's the trap. Just because you carried here doesn't mean you're going to do what? Carry over here. You have to be careful. So there's no carry involved, so 4 plus 3 is 7, and I have a different answer. Any question in that problem before we go a little bit further? Now, how many of you have done this before when you learned how to subtract? 1. That's the usual at best, 1. Now, was it in a public school? Really? In Modesto? Series. Interesting. Okay, because the last class, there was a couple of them locally and 1 in the Bay Area. So, and I've been arguing this for 30 years, so maybe it's finally getting through. I wish more people were teaching it this way. Okay, we ready to move on? Let's make it harder. Okay, so I have a 3896 here. 3896. Now, it's the same problem I did before, correct? But what I want to look at this point is what you would consider the classic method, where you borrow and check your answer. Let's just see what happens. So you could take 6 from. Now notice how I changed the way I said it. 6 from 8, and you still get the 2. 9 can't be taken from 6, so what do you usually have to do? You borrow from the 5, making it a 4. You make this a 16, and so you say 7 and 9. Well, you say probably 9 from 16 is 7. Then you can't take the 8 from the 4, so you borrow here, and you make that a 14, and the 8 taken from 14 is 6, and the 3 taken from the 6 is 3. Get the same answer, correct? Now, how do you check this problem?
Add up.
You take these two, correct? This is your check. And what are you supposed to do to get the check? Add them together, right? And get this answer. So let's do that. I'm just going to put a sort of a dash line here. 2 and 6 is 8. Agreed? 7 and 9 is 16. And what do you do with the 1? Carry it, right? You usually put a 1 above. Would you allow me to carry this way? 8 and 1's 9. Same game. 9 and 6 is 15. So I put down the 5 and carry the 1, and that becomes what? A 4.
7.
And 4 and 3 is 7. Now what I want you to note, what I have right here, okay, yes, chalk and I easily get separated. Now, will you look at what I have here and what I have here? They look alike, do they not? Same thing. Okay, so to that extent, the check is what you're doing with the Austrian method. It's just you don't have to first borrow to get there. Okay, let's really make it interesting. Okay, I have 3896 right here. 3896. And I want to subtract that number from a 70008. Now, do you understand the difficulty of this problem as a borrowing problem? You borrow from the 7, you make it a 6, you make this a 10, you subtract, you make it a 9, you make this a 10, you subtract, you make this a 9, make this a 10, you subtract, make this a 9, make that an 18. It sucks. Okay? So, what I'm going to do is the adding method, the Austrian method. So, what do I need to add to the 9 to make an 8 something? A 9. Do you agree? So I have a 9 here. 9 and 9 is 18. So what's going to happen to the 6?
7.
I'm going to change it to a 7. Is there any question there? Now again, if I'm blocking your view, there's a monitor you can look at and see it more clearly than you probably can from where you're seated. What can I add to the 7 to get something ending in a 0, namely a 10? A 3, agreed? So 3 and 7 is 10. That makes this a 10, but I'm going to have to carry from there, making that a 9. Now, what do I add to 0 to get 0? 0. No carry. What do I add to the 9 to make a 10? A 1, and that gives me a carry. And what do I add to the 4 to make 7? 3. Now that's the payoff. No borrowing. Now that brings up a question. And Debbie, I'll be going back to the center here. The question is, why go through this? What is the advantage of doing this method if you've learned to do the other one and you do it well?
You're checking at the same time.
Okay, you're checking at the same time. I think that's certainly an advantage because most people, when they go ahead and do a subtraction problem, they don't check. They just hope they didn't make a mistake. Interesting thought. The question, is there something more out of it that you get than just out of this process of avoiding borrowing and checking? And the answer to that is yes. The technique is what I present in an algebra class with signed numbers. Now, it's not my obligation to present signed numbers in here. That's not one of the goals I have. But I do want to talk about them to the extent that one of the units we do in the Orange Book involves graphing pairs of numbers. And we do need to talk about negative numbers or signed numbers. So most of you living in the Central Valley, when you listen to how cold it is in the winter, hear a positive number. It may get down to 29, 28, and in a really cold morning down to what? What's the lowest you remember it being? In Modesto.
Like 29, 27 maybe.
27? Sometimes in the surrounding areas they worry about 24. Maybe if you hear the forecast for the Sierra, 21 degrees. You don't get to hear a negative number. Now, if you live back in the Midwest and you call up for the weather report, today it's going to be 3 below. 3 below 0. What's another way of writing 3 below? -3. And so you have a negative number, a signed number. Can you picture that thermometer? Positives above, negatives below. Those are signed numbers. So on the sideboard, we're going to go over there for a moment, Debbie. So if you'll go to where I have that signed number, you're already there. Thank you. On that signed number, and we'll just stay there for a moment, I'm going to get something from the sippy cup. Good coffee. Okay. A -7, 7 below. What I've written here is what we affectionately refer to as a number line. I have positives to the right, negatives to the left. If you think of rotating this, watch the straight edge rotate like a propeller. The positives are in top and the negatives are in the bottom, correct? That's the way a thermometer is usually written. So if I have a -7, it's over here. Positives on the right side. And we call that a number line. And we're going to come back to that as we go along in the Orange Book. So I'm going to come up to a problem here and look at this one right here for a moment. Because this is a case where, let's say you call up the weather forecast and they tell you it's 7 below right now. And somebody tells you, man, it just got colder, it dropped 3 more degrees. So you were at -7 and dropped 3 more degrees, you're at what? -10. Now I'm going to change the problem to a subtraction problem in a different way. I'm going to ask, and I'm going to erase something here, Debbie, before I go to it. I'm going to ask, if I look at this problem, -7 minus a -3. Now this one was pretty obvious. You're at 7 below, you drop 3 more degrees, and so you're at -10. This one's not so easy. So we rewrite it as what? A vertical problem, and then I'm going to ask to do it as an addition. What can I add to a -3 to get to -7? I can add 4 more degrees below 0. -4 plus -3 gives you -7. And you don't have to learn any special rules. The special rule that most of us learn when we're in pre-algebra is if you have a minus sign in front of this parentheses and it has a negative, you change the negative to a what? To a positive, and you say -7 plus 4, which is still your -3. But when you try to explain I didn't do that well. I just realized as I looked at that, I was looking at the 3 when I should have been looking at a 4 and vice versa. This is negative a -3, which is the 3, and then that added to the -7 gives you -4. Same answer. Different approach. When I'm teaching a Math 70, an algebra class, I teach it using Austrian subtraction because it works. So the question is, how much do I want you to do with the Austrian method? And let's say that you do borrowing and you don't have any difficulty with it. I'd like you to do a few problems just to learn a new technique. Then it's your option. But here is the trade-off that you get in time. Now I'm going to have a problem here. This one is actually from the text. So let me rewrite it. This is 87,657. So 87,657. And this problem is, try page 25. Let's see if I'm right there. Try going to page 25 for me. And number, is it 3 or 4? 4A. So this is number 4A. So this is a homework problem. Now, the direction for this problem says to do what? Subtract and check. That's what you're supposed to do. Subtract and check. Classic method. You borrow, right? So let's do it as a borrowing problem for a moment. The 6 from 7 is no trouble. You're going to get the 1, agreed? It's the 8 from 5 that won't work, so what do? You borrow from the 6, making it a 5, and then you put a little 1 next to the 5, giving you 15. Then you take the 8 from the 15 and you get 7. You try taking 9 from 5. Won't work, so you do what again? Borrow, making that a 15. 9 from 15. The 6, agreed? Now, do I have to do anything here? No, just a 2 and a 2. But if I've told you to subtract and check, so this is your direction, what are you then obligated to do next? Take these two together, and usually I think of putting a dotted line here, dash line, and then you add these two together, agreed? So I have 1 and 6 is 7. The 7 and 8 is 15. I'm going to do what? Carry the 1. Now you don't put the 1 next to there. You put it above or make this a what? A 10. Okay? 10 and 6 is 16. That makes this a 5. 2 and 5 is 7. 2 and 6 is 8. And I get the same number. But when you focus on this, what do you actually see here? The Austrian method. So your check is just the Austrian method. So if I give you this direction, what's your choice? Use the Austrian instead, and you don't have to go through all this. So the same idea is shown here with the Austrian method. So this is with the Austrian method. Now just a comment, because there is a tendency to go ahead and say the wrong word. Austria is where? Near Germany, right? Europe. Arnold. Arnold who? Our governor. Okay. Now, many people want to say Australian method. Not the same place? Nicole is from Australia. Okay. We want Austria, so the Austrian method. Okay, just before I leave this, and I left this up because I wanted to remember to talk about it, vocabulary becomes very important, and I want to look at subtraction here a little bit more in terms of the words we use. But as I look at this, these 4 words you need to have part of your vocabulary. When you find the answer to an addition problem, we reference it as a sum. When you find the answer to a multiplication problem, we reference it as a product. When we find the answer to a subtraction problem, we call it a difference. These are pretty common for you. Here's the tough one, if there's one that's bothering you. When you divide, the answer is called a quotient. Now, we are focusing today right here on the difference. Vocabulary. How we say things really make a difference. Pun not intended. Just realized that that came out that way. Okay, so we're talking about difference and how we say it makes a difference. Let's look at these two statements here. So let me put a big box around this. Now again, what I do in my presentations is to try to present things so that when you take a pre-algebra or an algebra course, you have an advantage. You know the vocabulary, you know how to do things, and I've opened doors for you. So even though you may feel that the Austrian method is more difficult than you'd like to deal with, it does make things easier when you take algebra. Here's a case where vocabulary becomes very important later on. And I want you just to notice what happens. When I say, find the difference of, and I give you two numbers, they always stay in that order. So if I say the difference of 12 and 5, I mean 12 minus 5. Nothing changes. But if I tell you to subtract what? 5 from 12, you have to reverse the order. So here you're reversing the numbers, here you don't. And that's important to note because it'll come back and bite you if you don't understand it. Is there any question there? So difference of, things stay as is. The 5 and 12 are in this order. Difference of 12 and 5. But when I say subtract from, the 5 comes first. So just be aware of that. Try turning to page 23, please. I'm just going to leave this on the screen. Debbie, I'll walk off camera. We're going to go to page 23. On page 23, there is the typical problem. It's actually page 24. My apologies. Page 24. Here is how it starts out. Let's see if I can get this where I want it. A little bit higher. Okay, hold on, Debbie. It's got a mind of its own today. See if I can get this about there. Still working at it. Man, I'm simply not having any success here. We'll try this. Okay, here's the problem. I ask you on this page to take each of these and do them as quickly as possible, but I throw in a wrinkle. And the wrinkle is to use the Austrian method. Now, before you do those, if you're doing the Austrian method, what am I asking you to do? To do an addition problem, right? So the addition problem, still trying to get this where it's going to look like I want. There's the first one, and that's still not as clear as I want, Debbie. I'm going to try coming down. There we go. I'm expecting you to do what? Put a 6 there, and you're saying to yourself, 6 plus 7 is 13. So that's as an Austrian method, an addition rather than a subtraction. Okay. So the question, as you do these problems, how long should you be able to do, or how long should it take you to do 30 subtraction problems? Maximum, maybe a minute with the Austrian technique. And if you're really cooking, you do them how fast? 30 seconds. 1 second per problem. Now that's probably going to push you much faster than you'd like to be pushed. I don't want to take class time to do that, but maybe a little bit later, sometime this afternoon, get somebody to time you and see if you can do those in 1 minute or less. If you can, pretty good. If you have trouble with it, practice. Okay, I'm going to come back to another problem. See if I can get things to cooperate up here a little bit better. Now I give you the phrase, let's see if I can, let's try that, Debbie. This is number 6, and I ask you to rewrite each problem, lining them up. Now first, my comment. The order I've given them, notice the phrase, difference of. So that means you're going to take them in order. But what do I have to do when I write them down? What is your guideline when I rewrite these problems? Somebody explain to me. Okay. Line up what? The ones place, right? Another version. Line up what? Let's go back to the problem for a moment. Yes, the decimal point. Because there's a decimal point you don't see. In that first number, that 1, 0, 5, 7, 6, 3, 2, 4, what is at the end of that number always? A decimal point. So I could just line up the decimal points. And that's the thing I have to be careful of. Now let's look at the second one, and I can't. Okay, Debbie, coming off there. I ran out of space. But here's where the vocabulary becomes important. You're subtracting one from the other, so what do you have to do with the numbers? Rearrange them, correct? Let's go to the sideboard again where I have that little box, Debbie. Remember we said subtract 5 from 12. You reverse the arrangement of the numbers. Okay, is there any question there? Okay. Let's turn to page 187. Now I want you to be aware that on number 3, my directions are very specific. Subtract and show the check. This is number 3 on page 187. What is your option? The Austrian method if you want, and you don't have to show the check. But if you borrow, then I want to see the check. Now, how do I know if you've used the Austrian method? You would be carrying, changing the lower number, not the top number. So if you're borrowing, you change the top number. Let's look at it again. The top number is starting with the 6. So I'd be borrowing in this top number, crossing out things and changing the top number. That's if I borrow. If I'm using the Austrian method, only this bottom number gets changed. Now, one of the things I tried to do as I wrote this new version of this text this last year, I tried to provide more space. One of the things that's still a problem with the Austrian method is that the problem itself is a little bit squished. It's not open enough that you can change the numbers nicely. So if you want to rewrite the problem, you're welcome to. But notice now, in number 5, the directions are very explicit. Use the Austrian method. I do not want to see borrowing. Okay? Now, there are very few times that I will be that specific. But if you borrow in that problem, then I won't give you credit for your answer. I want to see the technique for the Austrian method. Is there any question there? Okay, now I'm going to come back to something that's on the front board because I want to set the stage for where we will be next week. Now, in terms of what we do tomorrow, we're going to be in the counting unit, and that's going to take all my presentation time tomorrow. But when we come back on Tuesday, we have a holiday Monday. On Tuesday when we come back, we'll be going into the 4th lesson. On Wednesday, the 5th lesson, and on the 6th lesson, which is, I should have said Thursday, for the 6th lesson. And you're going to have a homework assignment that may take you 3 or 4 hours over the weekend, which is a nice time to have that assignment. Now, it has to do with what I have here in the front board, and I'm going to come to that 6 that I have. I don't think you have to change too much, Debbie. I'm just going to rotate, move over here, and we looked at this problem, and I guess you'll have to slide just a little bit. We talked about the missing factor, right? So I could tell you that I can write 6 as 3 times 2. So I've taken a number 6 and written it as a product, notice my vocabulary, a product of two numbers, 3 and 2. Now we say that I have factored 6 into a product. Get the idea? 6 can be written as 2 times 3. Let's try 15. What can you multiply other than 1 and 15? What can you multiply? 3 times 5 is 15, correct? 21 is 3 and 7, right? 3 times 7. Now these numbers that we're talking about, 2, 3, 5, and 7, are given very special names. They aren't all odd. 2, 3, 5, and 7. They are primes. So that's what I want to talk about for a moment, because I have a little extra time with what I'm doing, and I need to set the stage. Prime numbers are numbers that can be written as a product in only one way. So for example, 13 is prime, because the only way you can write 13 is 1 times 13. 15 is not prime because I can write it in two different ways. 1 times 15 and 3 times 5. So I look at numbers and I ask if they're prime or not. So let's look at 18. Is it prime?
Yes.
Well, what numbers can you multiply to get 18? 6 and 3,
9.
2 and 9,
Sorry.
1 and 18. Therefore, it's not prime. 17.
Yes.
Just 1 times 17, correct? 23. I see a lot of people looking up into their head and checking to see what you could get for a 23. It's prime. 24. It's not. Why? 6 times 4? 2 times 12? What else? 6 and 4, 2 and 12, 3 and 8, 1 and 24, right? Okay, let me give you a very important statement that we're going to use in Lesson 6. If a number is not prime, by the way, we have a name for those numbers, composites. Composites, C-O-M-P-O-S-I-T-E, composite. So if a number is not prime, it is composite. So I start with a composite number. And here's what we're going to say. You can write it always as a product, meaning multiply, a product of prime numbers. You can always write it as a product of prime numbers. So 15 was what? Composite, and you wrote it as 3 times 5. 3 and 5 were prime. Now that's product of primes. So a composite can always be written as a product of primes. Sometimes it's not so easy. Yesterday in the algebra class, we did this same problem, but here's the number I gave. 2004. That was my number. What they had to do was write 2004 as a product of prime factors. Now we're going to have a whole lesson on that. And then we're going to use that idea to add and subtract fractions, to find common denominators. We're going to use it to reduce fractions. And it's one of the most important things in the pre-algebra and algebra curriculum. And most of my students coming into algebra 2 days ago could not remember how to do it. That was not good. So that's why we're going to take time to do it. So as I said, this was looking ahead to next Thursday's homework. Next Thursday, I will not be in the Orange Book.